to hands-on training with Math Compiler 3D. Today we're using beta version 1.1.962, and we're going to use the tall table video we created the other day and turn it into a parametric model. Now the first thing you want to do is hit F7 and turn on your axes so you know which way your X is going, because that's going to be your width. So if we select the top of the table here, and then we change it to a movement value of 1, you can see that width is on our x-axis. Okay. Now before I get started, I'm going to create a revision on this so that if I want to make a change, or if something gets messed up, or whatever situation, I could always revert back to my original version. So notice that the 1 comes in here automatically on the build. Leave the file name exactly the same and then hit create. Now up here you can see that we're version 1-0-1. Okay. So now we're going to go to equations, right click and add project node, and we're going to call this the control panel. Now this is your slate/virtual whiteboard area for equations. So if we go to the equations tab on the ribbon and hit add, then we get a sample equation here. I'm going to hit Shift and W. Now be very precise when you're using keystrokes on the virtual whiteboard or slate, because there's a lot of key presses embedded. So I want you to get the exact results that you're going for. It'll take a little bit of practice to get used to, but try that expert precision when using Shift and Alt in combination with other keys. Now we're going to hit save, and we're going to set our width to 4. Going to hit F6, which will do our dynamic compiling, and then we get our answer of 4. So this is the result and the value of the W equation. Later on we'll set our unit of measure. Okay, if we go back up to, instead let's go to 3D. Now we can look at both the equation and the 3D at the same time. So making sure that our table top is selected, we're going to right click and go to targets, size, and select width. Okay, that creates a target, so it will assign the results of the W equation to the width of this 3D object. So let's hit F6, and as you can see, the width of the tabletop is now 4. Okay, the next thing we're going to do is position the legs. So I'm going to go select the W equation, go Control F12, which duplicates the equation, and then I'm going to type in front right leg. Now, normally in math, you often have just single variable, single length variables. In the Math Compiler 3D, you don't have that limitation. They can be as short or as long as you want. So now I'm hitting Control plus to lengthen the equation variable. And I'll hit save. Now I'm going to select the 4, and I'm going to hit Control U, which adds a parenthesis set in here. I'm going to select the 4, hit delete because we don't want that in there. We're going to take the W that's here, and I'm going to select the X, and I'm going to go Shift W. So now we have a positive width divided by 2. So we're pulling the value of the result of the W into our equation here for front right leg. So I'm going to make sure my right leg is selected, and I'm going to right click on front right leg, and I'm going to go to targets, and instead of size this time we're going to go to position and position X. Hit F6, and notice that our leg is now on the opposite side that we wanted it. Select the plus, hit the minus sign, hit F6, and now it's on the right side, the right and the correct side. Okay, so now select the answer for front right leg. We're going to go Control U and add another parenthesis set. And if we go over to slate number 1, you'll see we have 4 by. So in here, we're going to type 4 by. Now, make sure that your variable names are exactly as they're spelled, because the system is case sensitive. If I had to put a lowercase f on this variable, then it would not calculate properly and give you an error. So now that 4 by is selected, I'm going to go Control plus and lengthen out so we can see the entire name of the variable. Now I'm going to hit F6, and notice how the leg is even with the edge and right where we want it to be. Okay, now I'm going to duplicate the front right leg equation by going Control F12, and this is going to be renamed to the front left leg. So we're going to want to flip the plus sign in the beginning and change this one to a minus sign. Then, making sure the left front leg is selected, I'm going to right click, go to targets, position, and position X. Hit F6 to recompile, and now that leg is right where we want it to be. And so let's stop and just do a quick test here. We'll go to 3 for our width, hit F6, and they're both moving correctly. So we'll go ahead and go back to 4 and hit F6, and now we can continue. Okay, so now I'm going to select the back left leg. I'm going to on the 3D object, and then I'm going to select the front left leg equation and duplicate it with Control F12, and I'm going to rename this to back left leg. Then I'm going to right click on back left leg, hit targets, position, POSX, hit F6, and now that back leg is right where we want it to be. Okay, let's do the same thing for the back right leg. So I will select that in 3D. Then I will duplicate. Let's see, this time, because I want this equation format, I'm going to duplicate the front right leg, F12. Now you can see our equation is over the top of our other one, and we're in equation movement mode as opposed to element movement mode. So if I hit Control and cursor down, then it moves the selected equation down right to where I want it to be. So then we'll rename this to back right leg. And then with that selected, we'll set object position of X, hit F6. All right. There's always time to stop and debug and figure out exactly what's wrong. So it's possible that I didn't have this leg selected, and maybe I added a second equation to the previous one. So I'm going to select this leg and look at targets. Okay. And I'll switch to the 3D view up here. what I'm looking for right now is I want to make sure that each one of these all has a target. Sorry, only has one target. And it looks like my back left leg does not have one. So let's go ahead and fix that. We'll go back to the control panel, switch over to messages here, go to 3D, hit the back right leg, right click, targets, position, POSX. Now, since this back right leg is selected, let's go ahead and verify. See, now we have a target in here, and we have our POS target field set. So we're good to go. Now let's test it and make sure it's correct. Hit F6, and now it pops right over to where we want it to be. Okay, and then we'll hit save. Now, our next goal is to set the shelf width to W. So I'm going to select the center shelf, right click on the W, and go target, size, and width, and then hit F6, and now that's the same length as the top of the table. Hit save. Okay. So now we need to position our shelf supports on each side. Okay, so the first thing I'm going to do is take an equation, and we'll use a left leg as our base. Go Control F12. And again, that was Control cursor down in order to move the entire equation. And we will call this a left shelf. Let's see, let's go left center shelf support. Again, let me remind you that you don't have to use your variable names this long if you're used to, algebra, geometry, calculus, and whatever. But if you're a software engineer, then you'll recognize this and completely understand why. So either way is completely acceptable. All right. So I am going to select the left shelf support, right click here, and set target, position, POSX. And that actually looks pretty good. Now I notice here that my shelf is just a little too long. So I'm wondering if this shelf is not actually positioned at 0 on the x-axis. So if we go to 3D data, we can kind of go behind the scenes here and notice the selected one is yellow. And we have TTX. So this is off. So let's change that to 0. And our Y position should be 0 as well. And we'll leave our T position, or sorry, our Z position, because that's exactly where it's supposed to be. So I'll go ahead and save that. And then switch back over to 3D. And now I'll go ahead and zoom in. And as we hit F6, then it pops right back into where it should be. So once in a while that happens. Always double check a drawing and see what state it's in before you start. And worst case scenario, you can do what we just did, diagnose the problem and fix it. Okay, so now we're going to select the left center shelf support equation, and we're going to rename this to right. And we'll swap our plus sign to a minus at the beginning, and then we will do plus on our 4x. So we'll select the right shelf support, right center shelf support, and go targets, position, POSX. And I'm going to go ahead and lengthen these by going Control plus, because right center shelf support was a little bit longer. Okay, so let's hit F6, and then our shelf support goes exactly into place where we want it to be. All right, looking good so far. Okay, so now the next thing we have to do is position our bottom shelf braces. So let's see, what do we want to use for our base equation? All right, let's use let's start a brand new equation. Control cursor down to position your equation. And we're going to call this front bottom shelf support. And then we'll select the blue variable, and we'll go Control plus to lengthen that out. Okay, so our X position is going to be 0. So for the moment, we're not going to set that one. What we really want to do is set the width. So I'm going to increase this 2 more times and add width onto here. So then we want W, and then I'll go Control U to add a parenthesis set. And then this is going to be a minus. And then we want 4x times 2. So if I select the 4x and I hit Control C, and then I select the X and hit Control V, then you can see how we copied the variable. So instead of divide by 2, we want multiplied by 2. So we have our overall width minus 4x times 2. So I'm going to select that front brace, right click, targets, go to size, and go to width. And then I'll hit F6, and behold, exactly what we were hoping for. Okay, so now that we have that pattern, then I'll curve this around so I can select the back one. And then I will select this equation, hit Control F12, and then this will be back. Bottom shelf support width. And the formula will be the same. Okay, now I could have used this same equation and added an additional target to it. But as you get into more and more complex, furniture in this case, or just 3D models in general, it's often better to explicitly assign each position. It's actually up to you. It's a preference. As you start to make more and more parametric models, then you'll get a feel for what works best for you. Either way is acceptable, but just keep in mind that whoever your consumer is, they have to be able to follow your design. Okay, so now make sure that back 3D object is selected. You're going to right click, go to targets, go to size, and go to width. hit F6 to recompile, and behold, doing exactly what we want it to do. Okay. The other thing you could do is you could extract this part of the equation out into its own variable, and then okay, so let's give an example here. Let's just say f, for instance. So you set f equals to w minus 4 by times 2, and you put the f equation right in this spot. Then all you would have to do is pull f down here so that you could use the same calculation but still have it be very clear which one it was going to. Again, personal preference and readability, that's the main thing. So, but for this video, I'm going to go duplicate one more and say this is the bottom shelf width. And for now, that's going to be the exact same equation. So I'm going to select the shelf, right click, go to targets, size, width, and F6. All right, it's looking good. If you go Control and mouse wheel, you can zoom in and out on your equations. And now let's practice with it a little bit. Let's go back down to 2, which is what we originally had before we started the parametric model. And if we want to go all the way up to 6 and hit F6 to dynamically compile. And so what you're looking at is a reusable formula. And this is very handy because now, instead of just having a static 3D object, you have, a dynamic 3D object so that you can use it for more than one purpose. So now if you wanted a long shelf in your shop in order to store tools, then you can make this up to 8 feet long, hit F6, dynamically compile, and there you go. Now, with it being 8 feet long, you may need a center support for your shelf because at some point 3/4 inch plywood will get a little bit weaker, but if you're just placing light things on, then you're good to go. But nevertheless, the whole point is to make this formula highly reusable. And there we are, a nice parametric formula. Thank you for watching this video and participating in hands-on training for Math Compiler 3D. Stay tuned for more videos that will show you new tricks and techniques in building 3D.